Somewhere in your environment right now, there is almost certainly an API key that was issued for a project that finished, a database credential created for a developer who left the company, a service account token generated to solve a specific problem in a specific quarter, connected to a webhook that stopped receiving events 18 months ago, a cloud provider access key that was supposed to be temporary, used once during a migration, and then forgotten inside an environment variable that nobody thought to clear. None of those are compromised. They are valid. They authenticate. The systems that issued them still accept them as proof of identity. And because they are still valid, they are still a risk, not because anyone is actively using them, but because anyone could. Stale secrets are credentials that have outlived the purpose they were created for. Not expired, not revoked, not compromised, just abandoned, still functioning, in an environment that has no mechanism to notice that the reason for their existence has passed. The reason stale secrets accumulate is structurally identical to the reason stale identity accumulates in any system. Provisioning has a trigger, and deprovisioning does not. A secret is created because something needs it. That need is a discrete event. A project kicks off, a service is built, a developer joins, an integration is configured. The need ending is not a discrete event, it is a slow fade. The project winds down over weeks. The developer moves to a different team before leaving entirely. The integration stops being used before the contract with the vendor officially ends. There is no moment where a system, receiving a clear signal, knows that a specific credential is no longer needed. The result is accumulation. Every environment grows its secret population over time. Active secrets are joined by secrets whose owners have moved on, secrets whose services have been replaced, secrets whose integrations have been superseded. The active population and the stale population are indistinguishable from the perspective of the systems that accept them. Both sets of credentials produce the same authentication event. Both appear in the audit log as valid, authorized access. The only difference is invisible to the authentication system. One set is being used for its intended purpose, and the other is being used by nobody at all, or by someone who found it. The discovery problem with stale secrets is more fundamental than it first appears. An active secret generates traffic. A monitoring system that watches for usage patterns has something to watch. An anomaly stands out against a known baseline. A stale secret, by definition, generates no traffic. There is no baseline, there is no anomaly to detect. The credential exists in the secrets inventory, or fails to exist in the secrets inventory because it was issued directly to a service without going through a central store, and produces no signal at all until the moment it is used by someone who should not have it. At that moment, the authentication succeeds. The access is granted. The audit log records a valid event. Nothing in the automated detection layer has a reason to fire, because a valid credential producing a valid authentication event is exactly what the system was built to accept. The staleness is not a property the system can observe. It is a property that exists only in the relationship between the credential and the context that originally justified it. A context the authentication system has no knowledge of and no way to query. Stale secrets cluster in predictable locations, which is useful for finding them even without a complete inventory. The first cluster is around personnel transitions. When an engineer leaves, the credentials they personally held are revoked through the offboarding process. If the offboarding process is comprehensive enough to include them, the credentials that were issued to services they built, pipelines they configured, and integrations they set up on behalf of their team are a different matter. Those credentials were not issued to the person. They were issued to the systems the person created, which continue to exist after the person leaves, and which nobody specifically reviews at the time of departure. The second cluster is around deprecated services. When a service is replaced, the focus of the migration is on the new service, ensuring it is configured correctly, performs as expected, and handles traffic. The old service is wound down. The credentials it used are wound down with it. if someone specifically adds that to the decommissioning checklist. Decommissioning checklists are less comprehensive than provisioning checklists in every engineering organization that has both. Secrets are removed from the service configuration. They are not always revoked at the source. The third cluster is around one-off operations. Infrastructure migrations, data imports, incident response actions, penetration tests, vendor evaluations. Each of these generates temporary credentials that are created for a specific purpose, with an implicit understanding that they will be revoked when the purpose is complete. That implicit understanding is not a revocation schedule, it is an intention. Intentions without mechanisms produce stale secrets. Detecting staleness requires asking a question that most secrets management systems do not answer by default. When was this credential last used, and is that consistent with its stated purpose? A database credential last used 11 months ago. In an environment where the database is accessed continuously by active services, is either stale or evidence of a dormant connection that is about to be used in a way nobody expects. Either interpretation warrants attention. Neither triggers any automated alert without specific tooling built to ask the question. The practical approach to stale secret detection combines last used timestamps with purpose metadata. A credential issued with a documented owner, a documented purpose, and a documented expected lifetime is auditable against all three. A credential issued without any of that context is auditable only against last use. And even then, the absence of use is not proof of staleness, because some credentials are held for low-frequency operations that happen once a quarter or once a year. The goal is not to eliminate every credential that has not been used recently. It is to establish enough context about each credential at the time of issuance that staleness becomes detectable rather than invisible. A credential whose purpose has ended should not require a person to remember to revoke it. It should expire or trigger a review or produce an alert through a mechanism that was built when the credential was created, not discovered when an incident makes the question urgent. Stale secrets are not a consequence of poor security practice. They are a consequence of systems that are better at creating access than tracking whether the reason for that access still exists. That asymmetry is the problem. Addressing it requires treating credential issuance as the beginning of a life cycle, not the end of a task.